Okay, good afternoon, students. Today we'll discuss the assignment number 4.1 of LP1. Okay, so yes, we just briefly look at the syllabus. Okay, is the screen visible, students? Shared screen.
Yes, sir.
Okay. So yes, in the HPC practicals of LP1, we have taken the second assignment, matrix and vector operations, in which we have seen parallel algorithms to add two large vectors, multiply vector and matrix, multiply two n by n arrays using n square processors. Using openMP, we did these three assignments. Then we also saw parallel sorting algorithms. We saw bubble sort and merge. It's not merger sort, it's merge sort using openMP. Now we start with the fourth assignment, which is parallel search algorithms. Binary search for sorted array. So we are going to see binary search algorithm for sorted array using openMP in today's practical. Okay. So yes, everybody is aware of binary search, I hope. How to search from a sorted binary using binary search. I hope you are aware using normal algorithm C, C++. Okay. So we divide the list into two parts, check whether the key is in the lower part or the upper part. If the key is in the lower part, we again divide the lower part into two parts, lower and upper part, and continuously do this process till we find a key or till the key is not found in the list. So either key will be found in the list or key will not be found in the list. So that is how binary search works. If you want to look it from the sample graphics of it, I'll just show it from the net to you. Okay. So binary search algorithm. So yes, suppose this is a sorted list, okay, and you want to find out the the seven number element or seventh value of element in the fourth index using binary search. First, what will they do? They will divide the list into two parts, lower part and upper part. Now, since 7 is low in the lower part, less than the mid value, 14 value, it's in the lower part. So it will search in the lower part. Then again it will find out mid 6 from the lower list. So since 7 is greater than 6, it will find it in the upper part of the divided list. Again, in the 8 will be the mid, 7 is less than 8, so it will search in the lower part of the list and it will find out 7 in the sorted list. So it will be doing fast computation, searching using binary search. Okay. So what is the worst case time performance? It is O of log n. Best case is O of 1 and average performance is O of log n. Okay, for binary search. Clear with the algorithm of binary search, how it works? I just briefly revised it. You must have already studied it in the second and third year. Okay? Yes, students, clear with that? Isha, Omkar, Ketki, Vaishnavi, others also. I hope you are aware of binary search how it works. Okay. Now what we are going to do is we are going to implement the binary search algorithm using openMP. Okay. So yes. So for openMP you have to include #include omp.h header file for openMP programs. Okay. Then in the main I have declared an integer pointer a, n number of elements for storing the number of elements, I key value to store the key, and location index to store the location. Okay. Enter total number of elements has been displayed. A equal to new int of n. A new integer array has been created and the starting element of address of the starting element of the array is stored in a pointer. So a is pointing to the array of n elements. Okay. The elements have been entered from the user. Enter elements. So C in A of I, the array elements have been entered from the user. Then which key is to be found out? Enter the key to find. C in key has been taken from the user. Which number is to be found using binary search for the sorted list? Okay. Then location equal to binary a comma 0 comma n minus 1 and key. So binary function has been called with the lower value of index 0 and the upper is the end of the array n minus 1 and the key value have been passed to the binary function. Okay. So what is the signature of the binary function? Okay, or prototype of the binary function. It is having array passed, integer pointer using the array has been passed to the binary function, starting index, end index and key. Okay, so binary int pointer star a, int low, int of high, int key. So 4 parameters are there for the binary function. So low has been passed with 0 value and high has been passed with n minus 1 value. Then int mid has been declared in the binary function. Mid equal to low plus high divided by 2. Okay. And then other variables have been declared. Low 1, low 2, high 1, high 2, mid 1, mid 2 and found and location.
Okay. Now using openMP syntax, they have given the statement hash pragma OMP parallel sections. What does hash pragma OMP parallel section do is that for each section within that code block, it allocates one thread for execution. So if our hash pragma OMP section, one thread will be allocated for this much part of the code. Hash pragma OMP section, next thread will be allocated for the remaining part of the code given within the section. Each section will be given a thread for execution. Okay, it will be parallelly executed. Okay. So low 1 equal to low, high 1 equal to mid. So what they are doing is that low 1 equal to the lower part 0 and high 1 equal to mid has been taken. Okay. So mid has been found out as the low plus high divided by 2. Okay. This is one section. And in the next section, low 2 has been taken as mid plus 1 and high 2 is taken as high. So this is the second part of the list, upper part of the list. And this is the lower part of the list. Okay. So in the lower part of the list, again, till low 1 is less than equal to high 1, if key is greater than equal to a of low 1, and key is less than equal to a of high 1, they are saying low 1 equal to low 1 plus high 1. That means key is in the basically between the low and the high. But it is greater than low but less than high. The low has been taken as low 1 plus high 1. Okay. If the key has been found at the mid, it is said to be found. If key is greater than mid, low1 equal to mid plus 1. So again the smaller lower list is divided into lower and upper list. And the key is
found out in each of the lower and the upper lists in the sorted list.
okay. So that way you can realize that the list is divided into lower list and upper list. And the key is trying to be found out whether it is in the lower list or the upper list and checked with the mid every time. Okay. If it is the found at the mid location, it is returned according to the location, the mid value is returned for that particular element. If that
Sir, you are not audible properly.
not audible,
No, sir.
actually internet is having a little bit problem from last 1 or 2 days. I just check again with my settings.
Yes.
Internet is having some problems. Okay. Is that disturbance or the voice is low? Yes, student, is that disturbance or voice is low?
Sir, there is some disturbance and your voice has changed. I mean, it's coming differently.
Is it better now?
Yes, sir, it's fine.
Okay. So yes, if the key is found at the location, then that particular value is returned, location value is returned where the key equal to the mid value, a of mid one, that is. Okay. Same thing is done for the upper part of the list also, where low 2 equal to mid plus 1 and high 2 equal to high. So upper part of the, so again it is into the hash pragma OMP section. So what does hash pragma OMP section do? It allocates one thread for that particular code section block. Thread will be allocated for that code section block to execute. Okay. So again, it will be executing the same logic, checking load. Only thing will be, instead of low one, high one, here it is using low 2 and high 2. It is the upper part of the list. Okay. So while low 2 is less than equal to high 2, it is checked whether key is greater than a of low 2 and key is less than a of, equal to a of high 2. Then low 2 equal to low 2 plus high 2. Okay. Getting the concept, students? How just the same binary search algorithm is divided into openMP program using hash pragma OMP parallel sections. Okay, so they are using hash pragma OMP parallel sections, and in that they are saying hash pragma OMP section to divide the code into sections, and sections are executed using threads. So if you want to see the help for sections, see here, parallelize sections of code with each section operating on one thread. So hash pragma OM, each section is operated by one thread. So in the hash pragma OMP parallel sections, if I say hash pragma OMP section and you write the code within the block, one thread will execute that section. Okay. Again hash pragma OMP section, next part will be executed by the next thread. Okay. By default, how many threads are created on a computer, students? Anybody recalls? For a computer, how many threads are created by default? Yes, students. Do you recall? If there is a just hash pragma OMP parallel, how many threads will be created by default? Yes, Nehal. Do you recall how many threads are or others also? Yes, Nehal, do you recall how many threads are created by default? See, how many number of cores are present in that computer? Isn't it? I told that in the previous few practicals. If you execute a particular openMP program on a multi-core machine, by default, how many number of cores are present in that particular computer? That many number of threads are created by default. Okay? Isn't it? So for core I3, it is 4 number of cores are there by default. So 4 number of threads are created by default if you don't specify the number of threads. Okay? But if you specify specific number of threads, that many number of threads will be created. Okay? Like for example, I had shown you that example. I just open that example again. Because you have not answered the questions, any one of you. See here. Suppose I have hash pragma OMP parallel. I don't specify the number of threads. I just say hash pragma OMP parallel. How many times hello world will be displayed, students, here? This is a core i3 machine. So how many times hello world will be displayed? Yes, how many times hello world will be displayed for this program? I'm using hash include omp.h, hash pragma omp parallel, and within that I'm saying printf hello world. So how many times hello world will be printed, students? Do you recall? 4i3 means there are 4 cores. So how many times it will be displayed now? 4 threads will be created. So 4 times hello world will be displayed, isn't it? Yes, correct, Snehal. So we'll just run it and see. Okay. So how to compile a openMP program? You have to say G++ program name -f openMP. On Windows and also on Ubuntu same way. If it's Ubuntu, you will say /a.out. If it's Windows, you will say a. So you can easily see how many times hello world has been printed. 4 times. Okay. So in the code, what is happening? I'm just saying hash pragma omp parallel printf hello world. So it has displayed four threads have been created because it's a core i3 machine, and 4 times hello world has been printed using the 4 threads. If I give specific number underscore thread as let's say 6, so now how many times will it be displayed hello world? What do you feel, students? I specified num underscore threads as 6. So if I execute this now, it has displayed 6 number of times hello world. Getting this how hash pragma OMP parallel works. That many threads are created, and according to that many threads, that much execution is done of the code within that blocks hash pragma OMP parallel. Okay. Here with this, Prajakta, Isha, Ketki, Anuja, Vaishnavi, others, Archit. So whenever you give hash pragma OMP parallel, whatever you write within the code, curly brackets, that will be executed by the parallel threads. Okay. So maybe I'll show you another example of practice assignment. Those who are coming for the first time, for them. Again, see, I've included omp.h. Now I've taken count here. OMP get number of threads. And I'm displaying number of threads. How many number of threads will be displayed, students, in this? How much count will be displayed for this line for our computer? Yes, student, how many number of threads will be displayed if I run this program? I have not used hash pragma OMP parallel. I'm only just getting the number of threads. I have not used the block hash pragma OMP parallel. They just get number of threads. So how many threads will be there for that in this program? What do you feel? It will be one thread, students. If you execute this program, because I have not used hash pragma OMP parallel. So if you look at the output, number of threads have been displayed as 1 because I have not used hash pragma OMP parallel. Okay, and the master thread ID is 0. OpenMP starts with a master thread ID. So what they have done, get number of threads, that will be 1 because hash pragma OMP parallel has not been used, and ID has been taken by OMP get thread num. So master thread ID is 0. Then now I am using hash pragma OMP parallel for. I am not using number of threads. And then I am taking count. OMP get number of threads and displaying the number of threads in for loop. So now how many will be displayed number of threads, students? Can anyone tell? I'm using hash pragma OMP parallel for. Hash pragma OMP parallel for. Now how many number of threads will be displayed for Core i3 machine? Count. I am commented the num underscore threads syntax. I am only saying hash pragma OMP parallel for. Do others agree with it that the count will be displayed as 4? That's correct. It will be displayed as 4 because I have not specified the num underscore threads. So if you execute this program and check, C++ program name -f -f openMP. Okay, and you execute the program. See here, number of threads are 4, and for loop has been executed 10 number of times, and each time number of threads are 4. Okay, but if I specify num underscore threads directly and I say 6, now what will be the count displayed, students? Now what will be the count displayed? 6. That's correct. Good. So we'll compile it and run and check, because I specified number of threads as 6. So see here, in the for loop 10 number of times 6 threads have executed the for loop. Using 6 threads the for loop has been executed of 10 iterations. Getting this, students? Yes, students, clear with this how number of threads are created and how you can assign number of threads, or by default how many number of threads are given by hash pragma omp parallel statement. Okay? Clear with this, students? Now don't get confused if I ask the question again. Yes, students, clear? Anuja, Vaishnavi, Vrushali, Archit, Snehal, Ketki, Prajakta, Daksha. Clear with this? Others also clear with this concept? Some of you have not attended the practical regularly, so I briefly just revise the concept. Okay? Okay, now we'll execute our binary search program. Okay? It is asking for the total number of elements. I'll say 5, which you have to enter in a sorted way. So let's say 10, 20, 30, 40, and 50. Now we want to find out which element is to be found out. So let's say I say 40. So key found at position 4. Okay. Getting the output of the program, how it works, binary search, students. So they have found out it from the sorted list, the key element, by dividing the list into parts and searching the parts of the list and then finding out the key element. In the case if I give some other element, it will say not found. So if I say like this, I say number of elements 5, 10, 20, 30, 40, 50, and enter key to be found, I say 60, key not found. Getting this, students? How it is working on openMP binary search? You already know binary search. It just how it works on openMP is what we are concerned with. So hash pragma OMP parallel sections. So what have they done? Just a minute, I'll just open the code again. I had opened the practice code earlier. Okay. See here. Hash pragma OMP parallel sections. So what will hash pragma OMP parallel do? Execute it using threads. And since I am saying sections, so per section, one thread will be allocated out of the 4 threads for the code written within the section. So one thread per section will be parallelly executing the sections. Okay? and that way computation will be done in the program. Getting this, students? Yes, Anuja, Vrushali, Snehal, Vaishnavi, Isha, others also. Getting how binary search will execute using openMP? Simple, you have to just modify the binary search algorithm with openMP syntax. Okay? Yes, students, clear with this? Now I've shown you the practice assignment also, those who are absent. Okay? So now you know how hash pragma OMP parallel works, those who are coming for the first time. Others already knew that. Okay? Yes, students, clear with this? Okay. How many of you are coming for the first time out of the students, or others have attended the practice? Anybody not attended previous practicals? I think most of you are regular students that have come, because not everyone has joined today's practical session. So those who are absent have not also joined today also. Okay. Okay. Are you understanding openMP programming, students? Why are you not uploading on the Google Classroom? Are you finding it difficult in completing the programs? Because not many, very few have uploaded the programs on the links shared on the Google Classroom. Okay. So try to complete the programs. Okay. Yes, students, clear with openMP programming basics now? So we have now only one more openMP program remaining, and then we have a CUDA assignment. So CUDA will be in the unit 6 theory. You will learn about CUDA in the unit 6. So CUDA programming, openMP, you have 3 assignments. One is extra assignment. So maybe if time permits, I'll take that also. So there are, out of the compulsory 4 assignments, there are 3 openMP assignments and 1 CUDA assignment. And there is a 5th extra assignment which is also on openMP. Okay. So let's see how it works out. And then maybe we took practice assignments also, 3-4 practice assignments before we started with the main assignments. Okay. So yes, I've shared the first 2-3 assignment links on the Google Classroom. So do upload the programs on the Google Classroom for those assignments. Okay. Okay, students, give me a couple of minutes. I'll just take your attendance.